Hello, my name is Tepang and welcome to this workshop on analytical geometry. Let's get right into it. Okay, so there are important formula that you need that's going to help you for analytical geometry. There's the distance formula, which goes d is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. That is the distance formula between 2 points. Then there's the midpoint of a line, which goes m into bracket x and y. That is the midpoint. The x and y coordinate is equal to x1 plus x2 divided by 2, comma y1 plus y2 over 2. That will give you the x value of that coordinate and the y value of that coordinate. Now there is the gradient of a line, which is given by small m is equal to y1 minus y2 over x1 minus x2. Then there are collinear points. These are points on the same line and thus have the same gradient because they are on the same line. Then there is the equation of a straight line, which is y is equal to mx plus c. Now here are some important things to remember. Horizontal lines have a y is equal to k equation where k is a constant. Vertical lines have a x is equal to k equation where k is a constant. Why does this happen? Because remember, the y1 does not have a gradient and also the x1 does not have any gradient. That's why these two are equal to k respectively. Then parallel lines have the same gradient. Perpendicular lines have inverse gradients such that m1 multiplied by m2 is equal to -1. So this just means whenever you have lines being perpendicular to each other rather, if you multiply their gradients, this will give you -1. Now the inclination of a line. The angle of inclination of a line is a straight line which forms an acute angle theta with the positive segment of the x-axis. The gradient of the straight line is equal to the tangent of the angle formed between the line and the positive direction of the x-axis. And this just means that the gradient is equal to tan of theta. So it's always the angle between the x-axis and that line, as indicated in these two diagrams there. Now let's carry on. More on inclination of a line. When theta is obtuse, we add 180 to change the negative angle to an obtuse angle, a different representation of theta. So looking at it there, all it means is that now if we want this theta here, all we need to do is, we know that alpha plus beta plus this guy here that we don't know, that will give us 180 degrees. So let me just call that guy x. So alpha plus beta plus x is equal to 180 degrees, right? Those are interior angles of a triangle. Also, we know that theta plus x is equal to 180 degrees. Why is this? Angles on a straight line. So this means to find theta, we will just have to find x first, right? And then say theta is equal to 180 degrees minus x. And that's it. Now let's carry on. Here's an example for us to do. So we have two straight lines and what we need to do is find the angle alpha. Let's quickly do that. Now, before we start, remember for vertically opposite angles, this will also be alpha. My slides are misbehaving. There we go. Got it. That is also alpha. Now let's quickly find alpha. What I'm going to do is I'm going to introduce sort of a Cartesian plane, a dotted line that is parallel to the x-axis. That'll help me here, right? Now, the reason I'm introducing that is so that I can find what this angle is. We know how to find that angle by saying tan of, let's call it beta. Let's call this guy beta. So tan of beta would be equal to m. Then we know that tan of beta is equal to the gradient of that line, which is 1. So beta would be equal to tan negative 1 of 1. Therefore, beta is just going to be 45 degrees. Now we're not done. Now we need to find this angle here, this whole angle. And we can find that. Let's quickly do that. We'd have to do the same thing where tan, let's call that whole angle x. Now tan of x is equal to the gradient, which is minus 3 over 2. Then x would just be equal to shift tan of minus 3 over 2. Then we can easily find tan on our calculators. Let's quickly do that. And I found my tan to be 123, comma 67. Now we don't want that whole guy, we just want alpha, which is here. So how would we do that? All we would do is alpha is equal to 123,67 minus 45 degrees. And what does this give us? This gives us 78,69. And that's how we do that one. Now that you understand what's going on, it's your turn to pause the video and attempt the following questions. Awesome. Now that you've attempted the questions, let's see if you're on the right track. So the very first question says, determine the equation of line AD in the form y is equal to mx plus c. So let's just take a look at that. Line AD. Okay. So now line AD, we know where it is. It's this line here. Now, what else do we know? We know that the coordinates of D, we know the y coordinate will be 0. So we don't know what x is, but we know that y is 0 because it's on the x-axis. Now, let's see what else they told us. They told us the equation, they gave us the equation of BC. So we know that if we put that in order, that'll be 2x is equal to minus x plus 14. So we took the x over to the other side. Now we need to divide everything by 2. So what we have is y is equal to negative 1 over 2x plus 7. Now remember that they said what? This is a parallelogram. This means that this guy is parallel to that one. Now it means that their gradients are actually the same or equal to each other. Now let's do this. We can use the equation of a straight line to solve this. So we know the equation of a straight line is y minus y1 is equal to m into x minus x1. Now this will be y minus 5 is equal to the gradient, which is negative 1 over 2 into x minus 1, close the bracket. So this is just y minus 5 is equal to minus 1 over 2 x, then minus 1 over 2, because remember this will be positive, but when the negative multiplies in, that will be negative a half. So this will be y is equal to negative 1 over 2 x minus 1 over 2 plus 5. And this will just be y is equal to negative 1 over 2 x plus 9 over 2. And that is the equation of line AD. Now let's carry on. Now they want us to determine the coordinates of D. Okay, that's fine. Remember, we know the equation of line AD. And line AD, it's y is equal to negative 1 over 2 x plus 9 over 2. Now to find D, we need to make x, we need to make y 0, because we know this is the x-axis, so y is 0 there. So we're just going to say 0 is equal to negative 1 over 2 x plus 9 over 2. Then we can continue solving. This is going to be 1 over 2x is equal to 9 over 2. Multiply both sides by 2, so x is just 9. So we know that the coordinates of D are 9 and 0. And that's it for 3.2. Now let's carry on. Now they're saying if the coordinates of F are 10 and 0. So let's just put those in. 10, sorry, not 10 and 0, but 10 and 2. If the coordinates of F are 10 and 2, show that DF is perpendicular to BC. Okay, remember the equation, right, of BC. We put it in order, and we found that the gradient of BC was negative 1 over 2. Now, what we need to do is find the gradient of DF and check if it's perpendicular to BC. So here we know that we have coordinates 9 and 0. So let's find the gradient. So m of df is equal to y2 minus y1 over x2 minus x1. Now this will just be 2 minus 0 over 10 minus 1. And what does this give? 10 minus 9, not 1, 9. My pen is just misbehaving because I'm writing a 9 and it just keeps changing it to a 1. So this is 2 over 1. That is the gradient of df. Now, if these are perpendicular to each other, when you multiply their gradients, that gradient needs to give you minus 1. So let's check. So 2 multiplied by negative 1 over 2. Yes, that will give you negative 1. Therefore, DF is perpendicular to BC. Awesome. Now let's carry on. Now they're saying calculate the length AD, well, the length of AD, and leave your answer in third form. So the length of AD, remember these were 9 and 0. So the length of AD will just be, so the distance formula DAD is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Then this will just be the square root of, then we can say it's 9 minus 1 all squared plus 0 minus 5 squared. And this is just going to be 10 squared plus 5 squared, and this will just give us the square root of 125, and that is just 5 roots of 5, and that is the final answer for 3.4. Now let's carry on. Hence or otherwise, calculate the area of parallelogram ABCD. Now the area of the parallelogram, remember, it will be, so if we have a parallelogram like this, it will be the base multiplied by the perpendicular height. And the perpendicular height in this instance is going to be DF. Now area is equal to length times, I'll just say perpendicular height. Now let's check. We just found what AD is, remember? Now we need to find that length of AD there, which was 5 root of 5. Then multiply it with the height DF, and we do have DF in our books. Let me just check the length for DF. It's root 5. Let's just put that in there, right? If you don't know how we found that root 5, you can just use the distance formula to find the length DF, because we have both coordinates, and it's going to be quite easy now. Then let's carry on here, and that will just give us root 5 multiplied by root 5 will give you 25. Then it will, root 5 multiplied by root 5 will give you 5. Multiplied by this 5, it will give you 25. And you can just check that on your calculator. And that is going to be 25 units. Let me just erase that. I wrote units, inventing my own English now. Units. squared. And that's it for 3.5. Now for 3.6, they're saying calculate the size of ABC, and look at the hat, it's on B. So this means that they're actually looking for which angle? Yes, you guessed right, this angle here. Okay, now let's quickly, my slide is misbehaving. Let's go back a little bit. There we go, it's this angle. All right, now if it's that angle, let's see what we can do. So I always like just introducing a new line there that is parallel to the x-axis, right, so that I can now prolong this line and find this angle. I'll call that angle x. Right, now I can say tan of x is equal to the gradient of AB. Right, now tan of x will be equal to, the gradient of AB is 1/3. And remember, now you are well equipped to find the gradient, so you can use the gradient formula to prove that this is actually 1/3. Now we can just say x is equal to shift tan of 1/3. Then we can find that angle there, and I can quickly check it in my book. I found it to be 18,43. Now let's prolong this line as well. There we go. Now we're going to find this big guy here, and let's call him beta. So we know that tan of beta is equal to how much? Is equal to the gradient of AD, right? If you don't want to use AD, remember it's parallel to BC, so it's the same thing. So tan of beta is equal to, I'm just going to check from my book, it's equal to -1/2. Now beta is equal to shift tan of -1/2, and that will give you beta to be how much? -26,57. Now as you can see, this is a negative angle, so we need to say plus 180, and this will then give you 153,43. Now all we care about is this guy here, right, in the shaded region. And how do we do that? That is just going to be beta minus x. Let's call that shaded guy alpha. So alpha is equal to this. So the shaded guy, I'll just say alpha. So alpha will be equal to 153,43 minus 18,43, and that will give you 135 degrees. There you have it. That is the value of B. Now let's carry on.